Welcome students, Standard 10, Subject Mathematics, Unit Arithmetic Progression. Now we'll see about arithmetic progression. What is arithmetic progression? First, we will see the definition of sequence. A list of numbers having specific relation between the consecutive terms is generally called a sequence. For example, 1, 3, 5, 7, 9, 11, 13, like that. Next term to a given is obtained by adding 2 with it. That is a sequence. Another sequence is also given here, 2, 6, 18, 54. That is the next term to a term is obtained by multiplying 3 with it. These are the some examples of a sequence. Now we see what is arithmetic progression. If various terms of a sequence are formed by adding a fixed number to the previous term, or the difference between two successive terms is fixed number, then the sequence is called AP, that is a arithmetic progression. AP is the short form of this arithmetic progression. Now we'll see example 2, 4, 6, 8 ... The sequence of even numbers is an example of AP. That means here all the even numbers are given, and we can find out the next term from 8 is a 10, because we can find out what is the difference between these two numbers. That is, in every two numbers, what is difference we have to find out, and then we can write a sequence, that is an arithmetic sequence, clearly. Now we will see next example. In this example, 5, 10, 15, 20, 25, these numbers are given, and next there is a dot. That means there are another many numbers are before 25, and we can find out which numbers will be next of 25. That will be 30, because we can find out the difference between two consecutive number, that is a 5 and 10 is a 5. That is a 5 plus 5 is equal to 10. And once again, 10 plus 5 is equal to 15, 15 plus 5 is equal to 20. Like that, we can find out the next number is a 30. That will become in this way, that is a 25 plus 5 is equal to 30. Same way, we can find many numbers which are in this sequence. In this, each term is obtained by adding 5 to the preceding term except first term. Now we will see illustrative example for AP. Now we will see here some figures are given here. Now you can see this is the first figure, which is a naming as A. Another, there is a this is a one. This is the first figure which is given here once again, plus D. D means difference. D means difference. Now the difference is given here. It is indicated by small letter D, where D is equal to 1, so that we can find out another two numbers. Second number, A plus D. Okay. Now come here and see A plus 2D means this is a A, and once again there is a first difference D, and another once again second difference is D, that is a plus 2D. Same way we can find out here A plus 3D, just A plus 1, 2 and 3D. In this way, these are the illustrative example for AP we can see here. Now we will see the general form of arithmetic progression is a, comma, a plus d, comma, a plus 2d, comma, a plus 3d. In this way up to a plus into bracket n minus 1 completed bracket into d. This is known as a general form of arithmetic progression, where a, this is a, which is the first term, which is known as the first term. Remember always these students, remember this one, a is the first term and d is called as the common difference. D is a common difference. So that for arithmetic progression we have to always remember that small a means first term and small d means the difference between two numbers. Okay, now we'll see next point, common difference. The fixed number which is obtained by subtracting any term of AP from its previous term, it is a common difference. If we take first term of AP as A and common difference as D, then the nth term of that AP will be in this way, A of n is equal to A plus into bracket n minus 1 completed bracket into d. This is the formula. We have to find out the nth term of that of AP. That is the arithmetic progression. So students, always remember this formula for finding out nth term of that AP. This formula is given, an is equal to small a plus n minus 1, which is given in a bracket into d. That is a means first value which is given in that sequence. Also n means which value we have to find out, minus 1 into d means difference. Okay, now we'll see next point. See here some sequence given here, 3, 7, 11, 15, 19 dot dot dot. Here we can find out the difference between two adjacent numbers. Now see here, 3 and 7 which are nearest number, and the difference between them we can easily find out. Subtract 7 minus 3, the number or answer will become here the 4, and that is the difference. Once again we can find out 11 minus 7 is equal to 4, that is a difference. So we can find out every two numbers, between two numbers there is a difference is same. So d is equal to 4 and a means first value which is given in that sequence is 3. Notice in this sequence that if we find a difference between any term and a term before it, we always get 4. 4 is called the common difference and is denoted with the letter D. To get to the next term in the sequence, we would add 4 so as a recursive formula for this sequence is an is equal to an minus 1 plus 4. Now this students, remember always this also formula. The first term in the sequence will be a1, which is sometimes just written as a. There are many terms are available in the sequence, so first term we can write as a1 also, but generally many times it is written as only by small a. So now we'll see in this sequence once again what is the difference and how can we calculate the difference. It is given here. See here, 7 minus 3, that is the difference is plus 4, or 3 plus 4 is equal to 7, 7 plus 4 is equal to 11, 11 plus 4 is equal to 15. 15 plus 4 is equal to 19. D is equal to 4. A is equal to 3. Each time you can want another term in the sequence, you add only D. So this would mean the second term was the first term plus D. Second term will be first term plus D. Students, also remember these words. Second term will become as the first term plus difference. The third term is the first term plus D plus D added twice. The fourth term is the first term plus a D plus D plus D added 3 times in this way. So you can see that to get the nth term we had like the first term and add D into bracket n minus 1 times. Students, remember this formula once again. An is equal to A plus n minus 1 into D. Now try this to get the fifth term. Suppose we have to find out the fifth term of that sequence. So we can write here in this way. A5 is equal to 3 plus 5 minus 1 into 4 is equal to 3 plus 16 is equal to 19. That means a fifth term is a 19. See here. In this way we can find out many terms by using this formula. Let's see an example. Here a is equal to 2, d is equal to 2, n is equal to 12. Find a of n. A of n is equal to a plus into bracket n minus 1 into d. Now putting the value of a, small a, that is the first term which is given here, 2 plus the value of n is equal to 12 which is given here, right here, 12 minus 1 into 2, difference is a 2. Now you can see here in this example 2 plus into bracket 12 minus 1 into 2 is equal to 2 plus 12 minus 1 is equal to 11. So here written 11 into 2, 2 plus 22, that is the answer is a n is equal to 24. Hence in this way we can solve this example. Now we'll see next. To check that a given term is in AP or not. Now see here 2, 6, 10, 14. This one sequence is given. Here first term is a is equal to 2. Find difference in the next term. Now a2 minus a1, that is 6 minus 2 is equal to 4. Also a3 minus a2, it is a3 minus a2 is equal to 10 minus 6 is equal to 4. Also a4 minus a3 is equal to 14 minus 10 is equal to 4. Since the differences are common, hence the given term are in a AP. We can easily find out like that. Now one problem is given. Find the value of k for which the given series is in AP. 4, k minus 1 and 12. Solution which is given. The example is solved in this way. Given AP is a 4, k minus 1, 12. This is a sequence. There is arithmetic progression. If series is AP, then the difference will be common. Now see, d1 is equal to, that is a1 is equal to a1, a2 is minus a1 is equal to a3 minus a2, k1 minus 1 minus 4 is equal to 12 minus k minus 1, k minus 5, that is this is the answer of this one, minus 5, 12, it is written here, minus k minus 1, that is a by solving this bracket it will be k plus 1, it is a minus minus plus. Now k plus k, that is a minus k is given here in this side, and minus 5 is given in this side. That 12 plus 1 plus 5, that is a 2k is equal to 13 plus 5, that means is 18, and k is equal to 18 minus 2 is equal to 9. Now we'll see the sum of the n terms. We find as sum is equal to n into first term plus last term, complete bracket, divided by 2. Now last term will be a plus n minus 1 into d. Therefore sum, that is a summation, addition, it is written as n is equal to n into bracket into curly bracket a plus n minus 1 into d, complete a curly bracket, divided by 2, complete this bracket, is equal to n upon 2 into bracket 2a, that is a plus a, plus that is a n minus 1, which is converted, and plus 1 into d. Okay, now we'll see next term. Derivation. The sum to n terms is given by Sn is equal to a plus d plus a plus 2d plus dot 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 a plus n minus 1 into d. Remember this equation. That is, as if we write this out backwards, we get Sn a plus n minus 1 into d plus a plus n minus 2 into d plus dot 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 plus a. This is the second equation. Now let's add 1 and 2. Then 2Sn is equal to 2a plus n minus 1 into d plus 2a plus n minus 1 into d plus dot 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 2a plus n minus 1 into d. That is, remember this equation, Sn is equal to n upon 2 into bracket 2a plus n minus 1 into d. Every student, remember this. Now we will see problem. Find a number of terms of AP: 100, 105, 110, 150. Alright. You can see in this example, first term is a is equal to 100, an is equal to 500. Common difference is d is equal to 105 minus 100 is equal to 5. Nth term is an is equal to a plus n minus 1 into d. 500 is equal to a is equal to 100 plus n minus 1 into difference is 5. Solving this, 500 minus 100 is equal to 5 into n minus 1. 400 is equal to 5 into n minus 1. 5 into n minus 1 is equal to 400. Now see here, 5 is into n minus 1 is equal to 400. N minus 1 is equal to 400 divided by 5. N minus 1 is equal to 80. N is equal to 80 plus 1, that is minus 1 taking in this side. N is equal to 81. Hence the number of terms are 81. Now in this way we can solve that example. Now we'll see second example or next example. Find the term, find the sum of the 30 terms of given AP: 12, 20, 28, 36. Solution. Once again see the problem. Find the sum of the 30 terms of given AP: 12, 20, 28, 36 dot dot dot. Now we can find out the solution of this AP is in this way. First see, given AP is a 12, 20, 28, 36. we know its first term is a is equal to 12. It is already given here. After that, common difference we have to find out is d is equal to 20 minus 12 is equal to 8. The sum to n terms of an arithmetic progression Sn. Here we have to write down equation of Sn, that is given here, n upon 2 into bracket 2a plus n minus 1 into d, completed bracket. After putting the value of all these, which values we have know that we have to put there. 1 upon 2 into 30 into bracket 2 into 12 plus 30 minus 1 into 8. Now here 1 upon 2 into 30, that is the answer is 15. Then 2 into 12 is equal to 24 plus 30 minus 1 is equal to 29 into 8. Now see, after that you can find out here the answer is 15 into bracket 24 plus 232, completed bracket, 15 into 246, and total the answer is 3690. That we can say that the sum of terms is 3690. In this way we can solve the examples. Now next, another problem is also given for you. Find a sum of terms in given AP 2, 4, 6, 8 dot 200. Solution. Its first term is a is equal to 2. Common difference is d is equal to 4 minus 2 is equal to 2. That we can know that here what is the first value and what is the difference. After we have to find out nth term, so we have to write here equation an is equal to a plus n minus 1 into d. Substituting values, 200 is equal to 2 plus n minus 1 into 2. 200 minus 2, taking 2 to this one side, that is in left hand side, is equal to 2 into n minus 1. Now 2 into bracket n minus 1, that is these values are given here, and what is the answer? 200 minus 2, it is given here 198. That is by only changing the sides of this equation. Now n minus 1 is equal to 99 and n is equal to 100. In this way we can find out which are the what is the value of n. Then sum to n terms of an arithmetic progression, we have to write down once again the equation of summation, that is Sn is equal to n upon 2 into bracket 2a plus n minus 1 into d. We have to find out 100th value, 100 terms, so Sn is equal to 100 upon 2 into bracket 2 into 2 plus into bracket 100 minus 1 into 2. By solving this, 50 into bracket 4 plus 198, 50, 202, that is a multiplication of both of them is 10,100. We can find out this equation or this answer in this way. So this is most important. Now we can see here the difference between two terms of an AP can be formulated as follows: nth term minus kth term, that is t of n minus t of k, a plus n minus 1 into d. This is the formula of nth term, minus a plus, we have to put here instead of n, k. We have to put here instead of n, that is a k minus 1 into d, Now it will become a plus n into d minus a minus k into d plus d is equal to nd minus kd, because the positive and negative sign having values will be get deleted. Hence Tn minus Tk is equal to n minus k into d. Now we can find out this kth term in this way. Okay, this was all about arithmetic progression. Examples which are given here, students write down in your notebook and exercise about this arithmetic progression. Okay, thank you.